Perfect. Well, thank you. And Mitch, that was excellent presentation. Thank you for that. I'm excited to talk some more about it after this. In the interest of time, looks like we're running a little bit behind, so I will make sure that I don't go over my presentation here. Keep it a little bit shorter, but thanks everyone for being here today. My name is Galen George. I am the Director of Applied Science at Felix Instruments, and I am happy to be here to present. Erwin invited me to talk about handheld quality sensors, so portable quality sensors, how we can use them in post-harvest quality assessment, harvest tracking, and more. So my background, also Erwin, go white. I did not know you were also a Michigan State graduate, so fun to learn that always. As I mentioned, I'm the Director of Applied Science. My background is in food science. Mostly, I have a lot of experience in food quality and safety assessment in the food, agriculture, and cannabis industries. And so what I want to talk to you today about is our line of portable quality meters, the F750 and F751. These are quality meters that we have developed and we produce here in Camas, Washington. And they utilize shortwave near-infrared spectroscopy, and we use interactance spectroscopy. So if you can recall all the way back to when Erwin was talking about the different kinds of spectroscopy, our device utilizes interactance in combination with some robust chemometric calibrations to give users the ability to acquire rapid, non-destructive measurements of internal fruit quality indicators. And so what this means essentially is we have a device that you hold up to a piece of fruit, you click a button, and the screen tells you some kind of quantitative concentration of some kind of indicator of the quality of the inside of the fruit. And so that varies depending on the commodity and varies depending on what the user is interested in. So what we offer currently are 3 different tailored instruments and then one more open-ended kind of instrument. And so the 751s are our commodity-specific instruments, and so those include the avocado quality meter, the kiwi fruit quality meter, and the mango. Those are our 3 commodities that we currently have actual models that are tailored for those commodities. And then we have a kind of more open-ended instrument that has some really good uses in things like high throughput phenotyping for breeders out in the field. For the avocado quality meter, we're measuring dry matter, and we've already talked about how dry matter is a good indicator of quality and of maturity in avocados, and that seems to be, what most of the industry across the world is now accepting as their maturity clearance criteria when they're going to harvest their fruit. And that has a direct correlation to oil content. So that's pretty much gives you an idea of how much fat, how much consumer acceptance is going to be within that avocado. For the kiwi fruit quality meter, we've been in development of this, and we're continuously updating all these instruments, as I'll mention later. But the 3 main parameters that we see for certain cultivars, specifically gold and red, are going to be dry matter, bricks, and internal color, because these are bred for specific internal colors. Flesh color, but then we want to make sure that we're also measuring that. So we use actually the hue angle to measure internal color. Since we can see everything from, if we remember back to the electromagnetic spectrum, visible light, so 380-ish nanometers, all the way through about 1100 nanometers, we get the advantage of having both the color spectrum and the NIR spectrum, which can show us more information about actual chemical constituents. So we can look at simultaneously both color and dry matter and sugar, as well as a variety of other internal constituents. And the mango meter, we focus on dry matter and bricks. So those are the two main parameters. We also have some users that also look at internal color as well as external color in the mangoes. And as I mentioned, our last device is that more open-ended device. We have people, all over the world that are not so interested in limiting themselves to, one of these specific commodities or just those specific parameters that are measured by these devices. And so people like tomato breeders will find themselves wanting a device that they can use to create these predictive models that will allow them to measure quantitatively carotenoids and chlorophyll to assess the different phenotypic traits within their different breeds and cultivars of tomatoes. And so that's what this device is kind of meant for. It's that open-ended, if you're interested in something that isn't a more straightforward application, then that's kind of why we offer that last open-ended 750 instrument. Just to talk about some benefits of the portable quality meters. And so these benefits, they're similar to the benefits of all the other sensors we're going to talk about today, but specifically with portable, quality sensors, the first one being non-destructive, not having to actually harvest any of the fruit to do any of the assessment. You can do it right on the tree. And post harvest, you can just go through and take scans of all your fruit, not have to worry about actually sending them to the lab to get destroyed to test for the internal traits like bricks or dry matter. They're rapid, right? So you can get those measurements in seconds, as opposed to in the case of dry matter for avocado, if you're using the oven method, that can take up to 8 hours or more, even in some cases overnight or a whole day. And requires, actual man hours to do that work, whereas you could get those same measurements in a matter of less than 12 seconds with the F751 Avo. Accuracy is another concern, and it's a great benefit when you're using an instrument like this, because not only is it something that is created as accurately as possible, but it's also something that is really helpful when you're looking for consistency across a supply chain, across a number of different farms. When you get into doing laboratory analysis, wet chemistry methods, even to do these destructive testing of internal quality traits, it can get pretty messy because you have different, levels of training. Some people are more comfortable in some methodologies than others. You don't necessarily have that ability to make everything cohesive and consistent across your entire operation or across the entire supply chain. And so having just a device that really takes the technical skill out of doing these analyses and allowing minimally trained operators, as I think Mitch put it, being able to operate these devices is something that's really useful. And since we use the best tools we have at our disposal to create these models, these calibrations, then we have very accurate models in combination with very consistent results. So that's a huge benefit of using these handheld devices. And then, of course, handheld versus something like an inline sensor is the versatility. So having a device that you can use in the field and then take it from that field and then bring it right into the pack house, use it in the pack house, use it further down at a distributor level, use it further down to an import level, all the way to retail. So having a device that can be used at all those different spots and even be transported, across your own organization and used at varying points is always something useful to have when you can't do something like that with larger machinery. However, and you'll hear this when Tomer goes to talk. That's at the trade-off, the expense of not having it be as high of throughput as something that can do, scan 400 things in a second, like an inline analyzer. And then the last thing that these portable handheld sensors can do to benefit your organization are to provide just better insights, because when you are limiting yourself because you know how much effort goes into doing destructive analysis for dry matter, for bricks, for whatever it is, chlorophyll, carotenoids, then you are going to, as a business decision, want to sample less, because you're going to be destroying fruit. It's going to take time, and you don't want to waste all those resources. So, with a device like this, the ability to collect as much data as you want, at a lower time cost, a lower cost of goods, because you're not actually destroying anything, to give you better information to inform your decisions at critical time points. So inform your harvest decision, to inform acceptance or rejecting incoming lots, if you're a distributor, an importer. So that's a huge benefit of having a device like this in your operation. And we have a lot of people that have adopted this kind of technology. Australia, in particular, were very keen and early adopters of using this technology across a couple of their industries. And so, in the avocado industry, Costa Group, we've worked very closely with them. Has multiple units deployed across multiple orchards. They essentially use it to monitor maturity in the field and help predict harvest, but then also use it in a post-harvest quality, as a post-harvest quality tool as well, when they're sending their avocados to storage. And then another good benefit of these tools is that we utilize a lot of open source and low code coding in our applications, so that we can easily integrate these into pre-existing traceability and mapping software. So, for instance, Costa had already their own enterprise solution for mapping maturity levels in their different fields, as well as making sure that the data was not able to be manipulated, that it was traceable. And so being able to easily integrate it with those systems was something that was important to them, was easily accomplished. And they also managed to use it successfully with 3 different varieties. So they were doing Haas, Maluma Haas, and Shepherd varieties. So it was a great success story for them. And we've had it now work in multiple other countries as well. A lot of happy customers with the SM51 Avo. The Mango is probably the one that's actually technically been around the longest, because one of the earliest interests and our earliest collaborators in this venture of creating these devices was Dr. Kerry Walsh at Central Queensland University, and his work with the Australian Mango Industry Association. And so, since they've been working with this technology now for running on 8+ years, I think, they've got dozens upon dozens of units deployed across all of their major growing regions. And they utilize them to monitor their maturity in the field, as well as in post-harvest situations. And they actually utilize a software that we've developed called Fruit Maps, that in combination with weather and soil data that they input, as well as the data that they collect in the field with the SM51 devices, are able to actually more accurately predict optimal harvest windows, allowing them to get to market as soon as they possibly can. So it's a very useful tool for not just the post-harvest stuff, but for the field, obviously, in predicting maturity. And the benefit of it being NIR spectroscopy, as opposed to just like an external colorimeter, as Erwin mentioned, is that when we're quantifying actual chemical constituents inside of the flesh, the internal flesh of the fruit, um, we are able to then integrate it with regulatory systems. So if there's for instance, a regulation stating that you are not allowed to harvest your avocados until they're 21.5% dry matter or 23.5% dry matter. Being able to actually quantify gives you that confidence to be able to say, okay, the majority of my crop is now above that threshold, and I can now safely harvest and know that all of my fruit is going to be of the highest quality when it reaches market. So a great benefit, and a lot of people with some good success stories. Now, that being said, this isn't a straightforward, simple device as it may appear. There is a lot that goes into the development of a product like this, and I kind of wanted to share that process with you. That's something that I think is important to share so that people can understand all the work that needs to get done in order for these kinds of tools to properly work and give that confidence that you need in a new technology that you might be thinking about adopting. And the best way I can discuss this is to actually go about discussing a product we're currently developing, and that is our melon quality meter. And this meter is going to be intended to be used with a whole different slew of cultivars of melons, not just honeydew and cantaloupe, but a variety of others as well. And so, how we started out with determining even what kind of a meter, a quality meter, kind of a sensor to make, is first we need to do our fair share of market research and figure out where is there a need for something like this, who actually wants it's like this. And this is where we really rely on input from industry leaders as well to determine key varieties or cultivars that are going to be important to be able to measure, as well as what metrics are we really going to be wanting to measure, as far as internal characteristics of the fruit. Once we've determined that, we'll move on to a more proof of concept study where we'll actually just go out and prove that is this instrument capable of measuring the quality metrics. And this is where we face a lot of barriers. And I know that we've already kind of touched this topic, but some challenges that we face when we're doing this are things such as penetration depth of light. So that was one of the first things I think that Erwin mentioned was talking about penetration depth. And if we're talking about an intact watermelon with a rind that's an inch thick, then you're right. You're not going to be able to measure anything but the rind with that light because the light's not going to penetrate into the flesh. Then you'd be relying on, is there some sort of correlation between what's happening with the flesh and what's happening with the rind? And in most cases, that's not always a very cut and dry relationship or a straightforward linear relationship of any kind. And such is the case with other melons too, though. So when you're talking about measuring Brix and melons, the Brix is developing from the inside out. So you're breaking down starches, and your Brix content is going to be increasing at the middle, and then it's going to get your Brix is going to develop more outwards over time as it matures. And so the difficult thing with that is, how can we go about monitoring or modeling Brix content when that is going to be changing based on the various time points throughout its maturity. And so what we do is we come up with a robust sampling plan for a single season model. And it requires us to really lean on the industry to provide us with some collaborators, and so people that are really interested in this technology, that are kind of forerunners in their industry, we'll meet with them and we'll discuss the idea of the project, and we'll ideally form a partnership to be able to help us collect data, because it's not like at our facility here we have massive amounts of land where we have every single commodity we could ever want planted, and we can just go out and collect data on our own. We kind of rely on the industry to help us collect this data. And so the more diverse our data that we collect, the better the model is going to be, because we're getting data from varying time points throughout its maturity. So from early maturity all the way through post-harvest, we're getting multiple cultivars. We're getting multiple regions, multiple growing regions. So all this diversity that we're using, we can then incorporate that into our models, and with the help of new, more advanced chemometrics and AI machine learning algorithms, can help us figure out with these giant multivariate data sets, right? We've got whole spectrum worth of data from thousands of different fruit from different areas and different maturities. And we're taking that, we're trying to identify, how can we predict a specific level of Brix in all these different things at all these different times. And so because of that, you can imagine that with classic linear regression that we talked about, that Erwin was discussing, that doesn't seem like it would be a linear relationship with all those different variables. And it's not. And so having something like a neural network, which acts more like a brain, is something that is able to take all those different data inputs and create a good predictive model for something like Brix and melon. So once we've got all that data, we then move on to beta testing. We'll send it to key industry players to help us make sure that the device is working the way we intend it. And of course, we launch. But as I mentioned very early in the presentation, there's no such thing in our line of work as a finished product, and that is because you can never just build a device with one season's worth of data and say this is going to work from now on. That's just not how it works. We're working with a living biological system. Climates change. There's going to be new regions appearing that are going to become new industry players. There's going to be new cultivars that are produced and bred, so the breeders are going to be doing their jobs well, and they're going to come up with new varieties for us. And so we're never truly finished. We just need to constantly improve our models over time, and so that's kind of part of the challenge of the portable sensors, is that it's not a one and done kind of device. It is you get it, you'll use it, and then you'll have to upgrade it, because we're going to be upgrading our models. And so that's one of the bigger challenges with these devices, is that it isn't a single stop solution like that. So when we're developing these, we have to always keep that in mind and try to educate all of our customers that this is an ever developing kind of concept. It's not just a one time purchase and you never have to touch it again or calibrate it or anything. But that is something that we'd like to see in the future. As far as regionality is concerned, that's a huge challenge that we face with this technology. So what we do is, when we find collaborators, we look all over the globe. And so we want to ensure that a device like this works not just for our US market, but for growers across the world. And so Italy, France, and Spain dominating the European market. We've got Turkey and Iran being huge producers, as well as India, China, Japan, South Africa, Australia, Brazil, and can't forget about Honduras and Guatemala being some of the biggest producers of melons as well. So we got to keep all of these things in mind when we're developing these kinds of this kind of technology, because what might work for California, actually might not even work in Arizona. What might work in Arizona and California might not work in Honduras and Guatemala. So diversity in data is the name of the game when it comes to these quality sensors. You can't just rely on a limited data set to help predict things that come from a more diverse data set. And so, looking at the time here, it looks like we're getting close. The future of quality sensing, where will the industry go from here? I, have given this a lot of thought, and there isn't like one end game solution, right? There isn't a single thing that is going to come out that is going to, make all this other stuff obsolete. Sure, there's all the improvements that everyone can make on their individual fronts. So portable sensors can always be smaller, they can always be lighter, we can always be more accurate. We can always, there's so many things that you can do on an individual level that can also apply to inline sensors as well, and UAVs, hyperspectral cameras, and multispectral cameras. Notoriously low resolution, hard to get super accurate results from. So there's always improvements to be made on individual levels. But where it all converges is something that we're very interested in seeing how all this interacts with each other. It's not so much as a competing. They're not all competing with each other. They're all kind of just complementing one another. And so the portable sensors are just a piece of the pie that completes the entire pie. And so the portable sensors can be used to help calibrate inline NIR sensors. The inline NIR sensors then help the large high throughput sensing as well as sorting, and the robotics, AI, the UAV multispectral stuff can be calibrated using portable sensors. The UAVs can help with mapping and plotting with harvest. Robotics and AI help with automating the harvest itself as well. So some kind of, where these all converge, some kind of fully autonomous, real-time AI-driven data analysis machine that's going to do everything all at once. Is it even a thing that's going to happen? It seems like it's more going to be a fully integrated system using these three different kind of sectors: the inline, the portable, and then the UAV kind of stuff, all kind of in one integrated system. Seems more like the route I think that things will probably end up. But yeah, so trying to keep this short and sweet so we can stay on the timeline here. But the portable sensors have, they've really just kind of hitting their stride, and we are really looking forward to expanding the applications. And you get requests every day from everyone asking about, what about this commodity? What about that commodity? And we're always interested in expanding. So it's really all about, if the technology is going to work for that application, then we can actually start looking into actual commercialization of something like that. So that being said, I think I'm actually pretty good under time here. So if people do have questions, feel free to let me know. But hopefully I got us a little bit more back on track for Tamra to follow up after the break. If you guys do want to learn more about anything that we do, please follow us on our social media. Feel free to contact us through email. Our website is a good place always to keep informed of new products. Like I said, we're in the development right now of a melon meter as well as a grape meter that is going to encompass wine, table, juice, and raisins. That is another big project to take on, a lot of data, but that's what we're here for is big data.